Hello and welcome to Learn ADS in 5 minutes. This is tutorial 5. In this tutorial, we will talk about real-time tuning feature in ADS. So if we recap, in one of the earlier tutorials, we set up this filter design bench and we simulated it from 10 megahertz to 0.5 gigahertz. While looking at the results, we obtained some filter looking response, but this was not pretty ideal or so-called very decent to look at. Now, if we have to change the component values in our design in order to improve performance, that can be done a couple of ways. One step is to go inside this circuit and start changing these values manually and rerunning the simulation to observe the change. But if you are very far away from your goal, sometime doing this could be a little problematic. So another way we could handle that situation in ADS is called tuning as well as optimization. So in this tutorial, we will focus on tuning, and the next tutorial video will be on optimization. To activate tuning, the minimum requirement is you need to have a simulation bench and you have some results plotted in your data display, which you would like to see the change. Now to activate tuning, we can click on this tuning bar icon here. And by clicking on this, a wizard will come up asking you to select a parameter which you want to tune. Now, the parameter which we want to tune is not on my main design, it's inside the subnetwork. So we can push inside the subnetwork and now we have the entire circuit available to us. Now by clicking on the parameters, not on the components. So if I click on this L parameter, you can see the L1 got added into the list. If you by mistake click on the component, that's no problem. It will ask you which value of that component would you like to tune, and you can select the appropriate value. So in this case, I will go ahead and select all 5 component values. And then we can put it together along with data display page so that we can see our tuning bar along with the plot which we are interested to see. Now each of these variables have their min and max defined, and if you need you could go ahead and define little more max, and you can reduce the minimum to, for example, 10, 10, and in this case so 10 for all inductors and maybe 1 picofarad for all capacitors. So you can set your own min and max, and using this either the slider icon or using this scroll icon we can go up and down. We can also decide on the step on which we would like to change the values when we click on these up and down arrows. Also, the values could be snapped to step. So if we select this option, now all the value changes we will do will only happen with respect to this step. But when we are starting tuning, let's not put that restriction for ourselves. So once we start moving the slider, at the same time you can see the response changing as well as the marker readout changing. Everything is dynamic, and by changing these values here, you could go ahead and start changing the behavior of a circuit because you're essentially changing the component values. So circuit behavior starts changing once you do that. So by putting in some effort, you can notice we have achieved a decent looking filter response. However, it's not optimum. But all the effort which we put in till now, we don't want to lose it. So we can go ahead and click on this store icon and we can store it with a name, let's say memory one, or you could give it any other name you want. Once we do that step, basically it stores this intermediate stage in the cache memory and we can start tuning again. So while we are tuning, you can notice the dotted response. That's our stored response, and we can start tuning it again. So once we reach to another level, and for example, if you want to store more, we can keep on storing as many results as you want and continue your tuning job. So if you realize for the moment that some other previous stages were better, we can always recall that. For example, I know memory one was probably the best one, so I could recall that state again. So once we are happy with the response, and you keep tuning till you want, but once you are happy with your response, you could go ahead and update the schematic, because while you are tuning, the schematic values are not getting updated. It is only the cache memory which is in action. Once you want to firm up the change, click on update schematic and we can close the tuning wizard. Now, if you go back and look at our schematic, you can see all the values updated as per your tuner value. So we can come up back again to the main design and we can give it one final run to make sure indeed everything has happened as we want, which indeed in this case you can see the filter response looks much more promising now, although we are still not meeting the desired specification. But that's your 5 minutes on how to use real-time tuning feature in ADS. Happy designing and see you in next video.